Hey everyone, welcome back. This is Mr. Korb. Today we're going to be learning about linear equations and laying the foundation of our solving linear equations unit, and also which will transfer into solving inequalities later on. But to do this, to illustrate this, let's take a look at this level. Okay, this level may look familiar because have you ever been to a park and you and your friend have been playing on one of these? This is either called a seesaw or a teeter-totter. You're going back and forth until someone is too heavy on one side and the other person is way up in the air, and then the person on the other side jumps off and this person hits the ground really hard, right? Okay, so nobody wants to be this guy over here, but watch what happens. If I let this go, it automatically goes back to an equal stance. Okay, this is the equilibrium. All right, it comes back to being equal weights on both sides. And this means that this is a perfect level because there's no weight on the right side, there's no weight on the left side. It's perfectly even, the weights are equal. Remember that word equal because that's what we're shooting for. Okay, so let's say that, here's me. I jump on this end. See what happens? There's more weight on this end than there is on this end. But let's say that my twin brother, which I don't have, but if I did, jumps on the other end, exactly at the same spot, and he's exactly the same weight. Hey, what happened? We are equal weights again, so that's why it leveled out. Whatever I do to one side, I have to add the same to the other side. Okay, so here's my son. I throw him on that side, and my twin brother has a twin-ish looking son, if that's possible. He pops on the other side. Whoa, what happened? Again, it's equal. If I add weight to one side, I have to do it to the other side to maintain that equilibrium, to make sure that they are equal. Likewise, if I take one off, what happened? They are unequal again, right? If I subtract from one side, I have to subtract from the other. Either it's subtracting, adding, multiplying, dividing, whatever I do, I must keep it the same, because then it's going to be equal. Make sure that you are always equal. Alright, so looking back in our notes, taking a look at 8-1, solving one-step equations, we're going to have to talk about our properties of an equality once again. These properties should seem familiar because we've used them in the past to look at just our properties of algebra in general, our algebraic properties. So let's take a look. Addition property. If we look at the addition property, it can add any value to blank blank of an equation, to either side. Okay, I can add any value that I want. If A is equal to B, then A plus C equals B plus C. We added C to both sides. You can add any value to either side, or maybe I should say both sides, of an equation, both sides of an equation, and make sure that when we added C, did we change the problem? No, it's just like those bricks. We kept it even. A was equal to B, so this is A is me, B is my twin brother, C was my son, and C was my son's twin, I guess. Okay, I added both to both sides, and that's what happened. Subtraction property. You can subtract any value from both sides of an equation. So if A equals B, then A minus C equals B minus C. Again, we took off our sons. We subtracted C from both sides. All right, let's move on to multiplication because it doesn't really change all that much. You can multiply both sides of an equation by the same number. That means if I multiply A times C and then B times C, it's going to still be the same. I'm keeping it level. Think about that equilibrium that we're trying to maintain. We multiplied both sides by C. Likewise, for division property, you can divide both sides. Remember both, and we divided both sides by C. Again, it maintains the integrity of the problem. Nothing has changed. Symmetric property. You can switch sides of an equation. So if 12 equals x, simply you can say that x is equal to 12. You can flip those around. And that's what that means. Our ultimate goal in solving linear equations is getting the variable by itself on one side of the equation. So if it's x plus 5 equals 12 down here, I'm trying to get x by itself. A one-step equation, that's what we're going to be working with first. A one-step equation means that we only have one number to get rid of in order to be x by itself. Again, we're trying to get x by itself. It's also called isolating the variable. So in our examples, we're solving for x. So here's the number I'm getting rid of. Here's the number I'm getting rid of. Here's the number I'm getting rid of. And down here's the number I'm getting rid of. Again, it's just one step to get rid of those problems. So solving, I think of inverse operations. So if I think about addition over here, if I think about addition, what's the inverse operation of addition? The inverse operation of addition is subtraction. Inverse, think opposite. Okay, if I subtract, then I have to add. So we have to do the opposite. So if I'm adding 5 here, I want to get rid of 5. I want to take 5 weights off of that level. So to get rid of it, I'm going to subtract from 5. But remember, what do I do to one side? I must do the same thing to the other side. So I subtract 5, subtract 5. What's positive 5 minus 5? That's just 0, so those are gone. So I'm left with x equal to 12 minus 5, which is 7. So in this problem, we have to get rid of our minus 12, so we have to add 12, because it is our inverse operation. So we add 12 to both sides. 10 plus 12 is 22, and that is equal to x. Bada bing, bada boom, you're done. Okay, moving on. Likewise, when we're talking about addition and subtraction, we also have multiplication and division. When we multiply, what's the inverse operation of multiplication? Division. And vice versa. Division becomes multiplication. And we'll talk about that. There's more inverse operations than this later within the course. We'll talk about square roots and squaring, and cube roots and cubing a function. So we'll talk about those later on. So we have multiplication, division, that's what we're going to try and do. So instead of multiplying by -4, we have to do the opposite. So we're going to divide by -4. Divide by -4. What is -12 divided by -4? It's equal to 3. So we have x equal to 3. All right, and you just solved it. Again, thinking opposite again. X divided by 8. If I'm dividing by 8, what must I do in order to get x by itself? I need to multiply both sides by 8. So x is equal to 80. All right, to wrap up today, just one last point I want to make is after solving, you can always substitute the answer back into the original equation to check your answer. We always want to plug those numbers back in and make sure that they do work. So you're checking your answer in this case. So if we think up here, if I plug 7 back in for x, 7 plus 5 is 12. So there you go. That's how we checked it. Again, 22 minus 12 is equal to 10. We're plugging those back in and solving. 3 times -4 is -12. And lastly, 4 is 80 divided by 8 equals 10. So therefore, we substituted those back in and checked our work. Next time, what we're going to do is finish up this first section of notes and discuss what reciprocals are and how we can use them to solve one-step equations and how it makes our lives a little easier. And then we'll move on to two-step equations, multi-step equations, and variables on both sides type of equations. So there's a lot coming. Just make sure you keep in mind that everything must be equal. Whatever we do to one side, we must do to the other. In conclusion, check out this video. See if the weight on either side of this level was equal. Have a nice day. This has been Mr. Korb. Talk to you later.
Oh, Scheiße!